Now let's talk about our list of non-singular equivalences, and let's add to that list. So, list of non-singular equivalences. This is for A n by n. You remember because an n by n matrix is the only one for which a determinant is actually defined. Okay, all of the following are equivalent. In other words, one is the same as the other. Each one implies every other one. 1, well, A is non-singular. 2, AX equals 0, the homogeneous system has only the trivial solution. And you remember the trivial solution is just 0, all zeros. 3, A is row equivalent to I sub n, the identity matrix. That's the one with all ones on the main diagonal, everything else is 0. 4, AX equals B, the associated non-homogeneous solution, has a unique solution, only one. 5, the determinant of A is non-zero. 6, A has rank n. 7, A has nullity 0. 8, rows of A form a linearly independent set of vectors in Rn. And 9, the columns do the same thing. The columns of A form a linearly independent, I'll just abbreviate it as Li, set of vectors in Rn. So I can make all of these statements. If I have some random A matrix, which is n by n, let's say 5 by 5. If I know that it's, let's say I calculate its rank and the rank ends up being n, I know that all of these other things are true. A is non-singular, that means it has an inverse. I know that the associated homogeneous system has the trivial solution only. I know that I can convert A to the identity matrix, in this case I5. I know that the associated non-homogeneous solution for any particular B has one and only one solution. I know that the determinant is not 0. I know that the nullity, the solution space, is 0, which is the same as the X is 0, it's only the trivial solution. I know that the rows of A form a linearly independent set of vectors in Rn. I know that the columns of A form a linearly independent set of vectors in Rn. So again, we have a matrix. The rows are a set of vectors, and they behave a certain way. They span a space. The dimension of that space is the row rank. The columns of that matrix span a space. The dimension of that subspace is called the column rank. The row rank and the column rank end up being the same, no matter what rectangular array we have. We call that the rank. The rank plus the nullity, which is the dimension of the solution space of the associated homogeneous system, is always equal to n. That's amazing, that's beautiful, and it's going to have even further consequences as we see in our subsequent lessons. Thank you for joining us here at Educator.com. Thank you for joining us for Linear Algebra. We'll see you next time.